Good morning, students. Welcome back to science class on the chapter of gravitation. Yesterday we had completed that chapter. So today, first we will discuss what we have learned in this chapter. Okay. So later we'll discuss some problems. See, first we discussed the law of gravitation states that the force of attraction between any two objects is proportional to the product of their masses and inversely proportional to the square of the distance between them. Okay, so first we have studied universal law of gravitation, that is F is equals to G into m1 take small m1 capital whatever divided by d square. Okay, the force of attraction is directly proportional to the product of the masses of the objects and inversely proportional to the square of the distance between them. Okay, next the law applies to objects anywhere in the universe. So this law is applicable anywhere in the universe. Okay, next gravitation is a weak force unless a larger masses are involved. If the masses of the objects means it is very less, then the force of attraction is very less. Okay, the force of attraction is weak. Force of gravitation due to the earth is called gravity. Okay, so here the force of gravitation due to the earth is called gravity. Next the force of gravity decreases with altitude. It also varies on the surface of the earth, decreasing from place to the equator. Okay, the weight of the place from place to the equator, from poles to equator. Okay, so here the distance is less, but here the distance is more because earth is not a perfect square. Okay, so that's why that g value, g equal to 9.8, right? 9 point acceleration due to gravity, that is g equal to 9.8 meter per second square. So this value changes from place to place. Next equator. The weight of a body is the force with which the earth attracts it. Okay, so we had studied the meaning of meaning of weight. Weight means it is the force of attraction between body and the earth. Next, the weight is equal to the product of mass and acceleration due to gravity. Yes, so if you want to calculate that weight, so for that we have to multiply mass of an object into acceleration due to gravity. So then we can get the force of attraction between the object and the earth. Okay. Then the weight may vary from place to place, but the mass always a constant. Okay, so mass is what do you mean by mass? Mass means it is measure of its inertia, right? So mass remains a constant everywhere in the universe, but the weight changes from place to place. Why? Because this g value is not constant from place to place. From place to place, this g value changes. So that's why this weight also changes. Okay, next. Mm, all objects experience the force of buoyancy when they are immersed in the fluid. Okay, so when you immerse objects in the fluid, all the objects they will experience an buoyancy force or upthrust force. Okay, next, objects having density less than that of the liquid in which they are immersed float on the surface of the liquid. If the density of the object more than the density of the liquid, in which it is immersed, then it sinks in the liquid. Okay, already in the previous class we have discussed it. Okay, when the objects are floats and when the objects are sink. Okay, see, one is density. For example, here I keep an object here. Suppose just imagine it is sinking, which means here the weight of this object is greater than the weight of this object is greater than the buoyancy force, or the density of this object is greater than the density of this fluid. Then it will sink. Okay, if suppose if one object if it floats here, then we can say that density of this object is density of that object is less than the density of the fluid, then it will sink, then it will float. Okay, and also we discussed why ships are float. Okay, because that weighs thousands of lakhs of weight, tons, right? So why? Because the thrust or the downward force or weight of that ship, which is less than the buoyancy force or upthrust force. So that's why all the ships are floats. Okay. Uh, so these things we have studied in the gravitation chapter. Now we will discuss problems. Okay. Calculate the force of gravitation calculate the force of gravitation calculate the force of gravitation between the between the between the earth and the sun and the sun given that given that that the mass of the earth mass of the earth is equal to 6 into 10 raised to the power 24 kg. And of the sun and of the sun 2 into 10 raised to the power 30 kg. The average distance average distance average distance between the two is yes sir. Find the answer for this question. I will give you 5 minutes time. Okay. Calculate the force of gravitation between the earth and the sun. Given that the mass of the earth is 624 and of the sun 230 kg. So the average distance between the two is 1.5 into 10 raised to 11. Okay, calculate the force of attraction. Quick. Yes, many students answered. Uh, 3.56 into 10 raised to 22 Newton. 3.5, 357.333 into 10 raised to 21 Newton. Okay, no problem. 10 raised to 3.56 into 10 raised to 22. Okay, see here. Let's check whether the answers are correct or wrong. First, what were the data given? So I will take mass of the earth as small m. Small m means mass of the earth. That is 6 into 10 raised to the power 24 kg. Then I will take mass of the sun. That is capital M. 2 into 10 raised to the power 30 kg. 30, just imagine. Okay, 13 lakhs of earth is equals to 1 sun. Okay. Next distance, d is equals to 1.5 into 10 raised to the power 11 meter. Okay. Yes, sir. We know the formula. What which formula? So to calculate force of gravitation, we know that one, that is F is equals to G into M divided by d square. Okay. Yes, sir. What is the value of acceleration due to gravity? Capital G value, that is 6.7. Okay, 6.67 into 10 raised to minus 11. So capital G is equals to 6.6 into 10 raised to power minus 11 Newton meter square per kg. Okay, 6.6 into Newton meter square and per kg square. Okay. Now, so substitute the values. So first, F is equals to G is 6.6 into 10 raised to the power minus 11 into mass of the earth is, that is 6 into 10 raised to the power 24 into sun, 2 into 10 raised to the power 30 whole divided by d square, that is 1.5 into 10 raised to the power 11 whole square. Okay. Yes, sir. So now here, first keep all the powers one side. Keep all the powers one side. So I'll write here F is equals to 6 into 6 into 6 into 2 into 10 raised to the power minus 11 into 10 raised to the power 24 into 10 raised to the power 30 whole divided by, now we can write 1.5 whole square into 11 into 2, that is 10 raised to the power 22. We can write like this. Okay. Now, first, operating the powers. See 6 into 12. Okay, 6.6 into 12 into, say, 24 plus 34, that is 54. Okay, so 10 raised to the power minus 11 into 10 raised to the power 54 divided by, here 1.5, so take 15 square. 15 square is 225. Okay, that is what is 1.5 square? That is 2.25. Okay. 2.25 into 10 raised to the power 22. Clear? Next, just multiply 12 into 6.6. 12 into 6.6. 12 into 6.6, that is 79.2. Right here. 79.2 into here minus 11 and 54, that is 43. 10 raised to the power 43 divided by 2.25 into 10 raised to the power 22. Clear? So take to the numerator. Take to the numerator. Here 79.2 into 10 raised to the power 43 into 10 raised to the power minus 22 divided by 2.25. Okay, so we will get 79.2 into 22, 43 minus 22, that is 21. Okay, 10 raised to the power 21 divided by 2.25. Okay. Now, so better here into 100 and divided by 100. So that is 7920 into 10 raised to the power 21 divided by 225. Okay, yes, so tell me the answer. Now first divide 7920 divided by 225. What is the answer? Quick. 7920 divided by 225. 7920 divided by 225. So you will get 35.2. 35.2 into 10 raised to the power 21 Newton. So this is the answer. Okay. So in short form, you can write this as F is equals to, you can shift out here, that is 3.52 into 10 raised to the power 22. You can write like this also. Both are correct. Okay. Yes, many students, 36 into 10 22, it's wrong. Okay, 3.6 into 10 raised to the power 22. Yes, that is over. Sorry, that is correct. Okay. Yes. Hope you understood this one. Next one. Sir, when is the test? Yes, sir. Tomorrow. Okay. Test. Tomorrow test. I'll send that link. You have to write. You have to take your test on that link. Okay. Yes, so here a stone is allowed to fall from the top of a tower 100-meter high, and at the same time another stone is projected vertically from the ground with a velocity of 25 meters per second. Calculate when and where the two stones will meet. Okay, so just imagine one is dropped, okay, from the tower, another one is projected like this. When and where the two stones will meet. Here that height of the tower is 100-meter. Okay. So now our work is to tell when and where the two stones will meet. Okay. Yes, sir. I'll give you 3 minutes time. Find the answer for this question. Quick. Yes, sir. After 4 seconds. Okay. 80 meter. What is that? See, don't copy from your guide. First one we will discuss. Okay, first case dropped from the height. Dropped. Okay, dropped from the tower. Okay, so while dropping, its initial velocity is equal to 0. Okay, then what about g? That the g is constant, right? G is equals to 9.8 meter per second square. Okay, so now see, dropping from here, the distance is 100 meter. Now one is projected. Just imagine both the objects will meet somewhere here. Just imagine. Okay, see, here to here 100 meter. Now first we can calculate this distance, the distance covered by this object. Okay, so first I am calculating the distance between when you drop that object from the tower. Okay, So that is S is equals to ut, S is equals to ut plus half gt square. Okay, so here 0 into t, I don't know time, so half into 9.8 into t square. Okay, so what do we get? 0 into t, so that is a 9.8 divided by 2. What is the answer? So here we will get 4.9. Okay, so 4.9 t square. Clear? So S is equals to 4.9 t square, means the distance from here to here, that is 4. The distance covered when you drop the object from the tower, this distance is equal to 4.9 t square. Okay, now second case, projected upwards. Okay, second case, for the stone thrown upwards. Thrown upwards. Okay, see they have given right, and the same time another stone is projected vertically from the ground with the velocity of 25 meter per second. So we can write u is equals to 25, u is equals to 25 meter per second, and g is equals to now here minus 9.8 meter per second square. Okay, so now also see, now we can calculate this distance. Okay, so I will take this distance as s dash, s1, like this, s1. Okay, we know the formula, that is s1 equal to ut plus gt square. Okay, next, what is u? U is 25 into t plus half into gt square, right? That is half into 9 point minus 9.8, half into minus 9.8 into t square. Okay, then 25t plus into minus. Okay, so 2 was a 9, that is 4.9 t square. So we got s1. Okay, the distance that thrown upwards of this object's distance, that is 25t minus 4.9 t square. Okay, 25t minus 4.9 t square. You know they have given what, that object is dropped from the tower of height 100 meter. The distance from here to here 100 meter. Okay, so now can I write like this? Yes, so here we got this distance s is equals to, and this distance s1 is equals to. So here the distance is 100 meter. So we can write s1 plus s is equal to 100. Okay. Next, so what is s1? Substitute here. S1 is 25t minus 4.9 t square, and here plus 4.9 t square equal to 100. See here, cancel, minus 4.9 t square, and now this is 25t equal to 100. Then t is equals to 100 by 25. So that is 4 seconds. Okay. So after 4 seconds, see here we have to drop this object from this point. We have to throw this object from here. So we have to drop, and that we should throw that away at the same time. So after 4 seconds, both the objects will meet. After 4 seconds, both the objects will meet. So now when and where we should calculate that one, right? So here we got a t equal to 4 seconds. Okay. So now you can substitute that here or here. So better I will substitute here. We got a t equal to 4 seconds. Okay. So s is equals to 4.9 into 4 square. I substitute here in this equation. So that is 4.9 into 16. So what is the answer? 4.9 into 16. into 16, that is 78.4. Okay, so yes is equals to 78.4 meter, which means see here the distance from here to here, that is 78.4 meter. Then what about here to here? See, whole 100 meter, here to 78. So what about here? So that is, we can write S1 is equals to 100 minus 78.4. Okay, so what is the answer? 100 minus 74, that is 20.6. Sorry, 21.6. Okay, so 21.6 meter. So now the distance from the top. Okay, if you take from this here from the top, at that time 78.4 meter. At that point both will meet. If you take from the surface, that is 21.6. At this position both the objects will meet. Clear? So when end where? So 21.6 meter from the ground or 28.4 meter from the tower, they will meet after 4 seconds. Okay. I will stop here. So tomorrow I will continue the class. Thank you.